This is problem number 7 from section 2.3. In this problem it says, as the altitude increases, both air temperature and the dew point decrease. As long as the air temperature is greater than the dew point, clouds will not form. So if your air temperature is larger than your dew point, they're essentially saying the clouds will not form. Now, this is the case at ground level. At ground level, typically your temperature is much higher than your dew point, so we don't have any clouds at ground level unless we have like fog. So here they talk about typically the air temperature, T, cools at 19 degrees for each 1 mile increase in altitude. And the dew point, D, decreases by 5.8 for each 1 mile increase in altitude. So they both decrease, but the dew point decreases at a slower rate than the temperature. Temperature decreases pretty quickly. So in part A, they say, suppose the air temperature at ground level is 67 degrees Fahrenheit. Write a formula for a linear function T that gives the air temperature at X miles high. So they want us to write a formula using T as a temperature, and this is supposed to give us the temperature at any height in the air. Well, let's start by saying T equals, and they tell us we start at 67 degrees. So T equals 67 degrees Fahrenheit. And we know from the problem that they say the air temperature cools at 19 degrees Fahrenheit for each 1 mile increase. So we're going to say 67 degrees Fahrenheit minus 19 degrees Fahrenheit, and I'm going to put this like this, times the miles we go in the air. And you can see I've written here X equals number of miles high. So we want to 1 mile up, now we subtract 19 from that, that's 48 degrees. We do the same thing again, we're at 29, so on and so forth. Now part B says, suppose the dew point at ground level is 51 degrees Fahrenheit. Write a formula for a linear function D that gives the dew point at X miles high. So again, we're going to start with D, and we're going to say that 51 degrees Fahrenheit is where we are starting at ground level, but they tell us that it decreases 5.8 degrees per mile increase. So minus 5.8 degrees Fahrenheit per mile increase. So this is the formula for finding the dew point as we increase. So 1 mile up, we're subtracting 5.8, 2 miles, we subtract 11.6, so on and so forth. Part C, it says determine symbolically altitudes where clouds will not form. So if we go ahead and determine this symbolically, we go back to the beginning, it says, as long as the air temperature is greater than the dew point, clouds will not form. So clouds won't form if the temperature is greater than the dew point. So let's take this equation and set it greater than this equation. Let's ignore the degrees Fahrenheit for our labels here, so it just makes it easier to look at. So 67 minus 19x, temperature has to be greater than 51 minus 5.8x. Let's go ahead and solve. So we'll add 19x over. And that gives us 67 greater than 51. Let's see, negative 5.8. Plus 19, 13.2. So we're going to say plus 13.2x. Now we can subtract the 51 over. And that's going to give you 16 greater than 13.2x. Finally, we can take 16 divided by 13.2, and we get 1 point, I'm going to round it to 2.1, greater than x, and I'm going to rewrite that, so x is on the left side, so x less than 1.21. So, as long as we stay lower than 1.2 miles in the air, clouds are not going to form. But as soon as we get to 1.2 miles in the air, now we start to get some clouds. All right, so that's part C. Now part D, we're going to use the calculus. It says solve part C graphically. So graphically means we're going to use, obviously, either we're going to draw it by hand or we're going to use our calculator to do so. I think our calculator makes the most sense here. I'm just going to delete these out, show you how to type them in so we can make this quick and easy. So we're going to type the first equation in. We're going to use the temperature equation, so 67 minus 19x. Then we'll type in the dew point, so that's 51 minus 5.8x. All right, now we're going to hit enter. I'm going to slide this up a little bit, hit enter. We're going to make sure our window is in a good spot. So let's go to our window and let's put in negative 30, let's go negative 50 to 50. Well, actually, we're going to do the x values because the x values, right, that's going to be the, remember x stands for the number of miles high. Well, we're not going to go that high. So let's maybe just do negative, we'll go negative 2 to 2, going up by 1s. And then for the y's, our temperature can get a little high. So let's go from the min for the y. We'll go from well, lowest temperature is probably going to be 0. Max will go up to 75. And let's go up by 5s there. All right, graph it. Okay, you can see our lines there. Now we want to see where they intersect. So let's go ahead and hit to intersect. There's a calc button here. It's blue. It's right above there. It says calc. We hit the second button in the calc, and we can click on intersection. And the calculator will actually guess for us where this is. So we're going to click this blue, hit enter. We're going to go over to the red. And you got to go on the other side of the point. I usually do that. That gets you the best guess. And you can see the intersection is the x value right there, and it says 1.21. So you can see why we got a solution when we did it symbolically of 1.21 as being our max value. Everything below that works.